Also, David, can you admit people? All right, so that I was looking at it, but maybe it's easier if you can admit people. Fantastic. So perhaps while we're waiting more people to connect, welcome everyone to Close the Loop with Nature partner event of European Green Week, and a couple of words about the European Green Week itself. It is an initiative by European Commission directly, by DG Environment, and in fact, they are organizing this week for already 25 years for this event. And they use it to promote, let's say, latest and upcoming developments in European environmental policy. Each year they have a different theme and they cover a different topic. So this year the overarching theme is circular economy, and they titled the event Circular Solutions for a Competitive Europe. As they said, they would like to unpack the three C's, clean, competitive, and circular. So the idea is to explore how circular economy can be in the center of European economic transition. Every year, or at least lately, they're organizing the event, let's say, in two streams. So there's always a conference in Brussels that happened last week, and they organize a series, or they invite the floor for a series of partner events. So this year, around 100 events contribute to the European Green Week, and our event is one of the partner events. Maybe just as an what they did this year, and I'm not used to this before, so they have an European Online Circular Museum that you can also visit. It's in as a part of the European Green Week. So I'm sharing first a link to the event that happened in Brussels last week. It was recorded, so potentially you can watch the recording, and also the link to this European Circular Online Museum. Not to have introduction too long, and perhaps people will anyway join a bit later, quickly looking at today's agenda. So the webinar is organized by three projects that are joining the same goal. So we are all focusing on nature-based solutions. Those projects are CARDIMED, NATMed, and DesirMED. To set the scene, we will quickly discuss what is circular economy and what are nature-based solutions, and what are the potential overlaps. We will continue with highlighting the exact, or like case studies from each of the project, how circular economy is implemented in our projects. And then we will finish with the discussion where everyone is invited to ask questions and share your thoughts with the speakers or among each other. And at this moment, I would give word to Jesus Iglesias to make a short presentation about circular economy and MBS.
Thank you, Tadek. Thank you to all the organizers. It's a pleasure to be part of the EU Green Week. So let's discuss the relationship between nature-based solutions and the circular economy. So do you see my screen?
It works.
Okay, thank you. So basically, first, an understanding of what is the concept of nature-based solutions and what it means in terms of the IUCN Global Standard that defines the different criteria that a project has to meet in order to be considered nature-based solutions. First of all, just to set the context, try to differentiate what is a nature-based solution compared to what is a nature-derived solution and a nature-inspired solution. So nature-based solutions draw on ecosystems, use ecosystems, natural elements to create benefits for societies and for biodiversity simultaneously, as compared to nature-derived solutions that are using natural elements to drive technology and create artificial solutions to other problems. And nature-inspired solutions are solutions that are mostly artificial, but get inspiration from certain features, certain functions of nature, but use more artificial materials or energy streams. So that's important to differentiate. Also, the fact that nature-based solutions can be incorporated or can be complementary to existing great infrastructure. So it's not one or the other, but it's using nature to complement and enhance the features and functions of existing great infrastructure. So you can have the benefits of both worlds. That's the idea. You can see here we'll discuss later this example, what's called constructed wetlands that use artificially constructed wetlands to filter urban wastewater and try to regenerate it for agricultural purposes. Another synergy between gray infrastructure and green infrastructure or nature-based solutions is what's called naturalized and multifunctional solar farm. So it's a regular solar farm that has a vegetation cover underneath, and that vegetation cover also provides shade to animals that can feed from the grass as well. So there are multiple synergies because the shade from the solar panels creates a positive environment for grass and for cooling of animals and vegetation alike. And that reduction of ambient temperature benefits the functionality of the solar panels, the effectiveness of solar panels, efficiency, sorry. So if we come to a definition, the one most commonly accepted is the one put forth by the IUCN, International Union for Conservation of Nature, that defines NPS as actions to protect, sustainably manage, or restore natural or modified ecosystems. Most ecosystems on Earth have already been altered by human societies. To address societal challenges or challenges of human societies effectively and adaptively, we'll see that later. Creating benefits simultaneously for humans and biodiversity. That's important. The biodiversity is at the same level as human societies when it comes to benefits. What are the societal challenges that we want to address with these solutions? We're talking about climate change, of course, and all the impacts derived from that, economic and social development of communities, human health, creation of green jobs, building community resilience, protecting human societies from disasters, so disaster risk reduction, future and food and water security, the loss of biodiversity, and other challenges at the whole societal level. So what is a nature-based solution in practice? You could say that a tree is a nature-based solution in the sense that it provides benefits, like it protects both animals and humans from heat stress. And in that regard, it could be a nature-based solution. But we're looking more into a landscape, seascape scale. And this infographic shows a little bit what we're discussing here. We've got an original ecosystem. We're talking about a coastline ecosystem in this case that is being degraded by human anthropogenic forces like climate change, increase of sea level rise, and also extreme urbanization of the coastline degrades the functionality of sand and dunes and beaches in general to protect from flooding, right? So in the third figure, we see a restored ecosystem. Mangroves along the coastline have been restored, as have been reforestation upstream from the rivers, so they protect from flooding, both from the sea and from the delta. And that's been combined with the gray infrastructure, like a seawall, and also a river wall that protects nearby communities from flooding. So you see how this works in process. Some examples in real life. In an urban environment, you see different types of green walls, green roofs, also the regreening of different transport infrastructure, suits or sustainable urban drainage systems to prevent flooding and also recharge aquifers. Also different types of parks, urban corridors that create biodiversity rings around the city. So these are all solutions to reduce the ambient temperature in cities, to increase biodiversity, to protect us from flooding, etc. In the urban context, it's quite clear, but as is in the rural context, we see here the typical example of a regenerative farm. There's like sort of a mosaic of different land uses, but they're all connected to the surrounding environment, and biodiversity, wildlife in general, penetrates the farm and increases the production in that regard. So there's a synergy between, productive farming and protecting biodiversity and wildlife. But also the simple fact of removing invasive species of exotic species from ecosystems that are being damaged by this, the introduction of these such invasive species, is considered an NBS because it's an action to sustainably manage an ecosystem, right? So the simple fact of removing invasive species can be considered an NBS itself. We don't have to sometimes rebuild nature, just protect it. But we need to fit or meet 8 criteria for a project to be considered an NBS. We will discuss this with examples one by one. First one, we already talked about this one, is addressing societal challenges like flooding or droughts, any impact from climate change in this regard. It has to be at a societal level. And without we get into criteria number 2 on scale, the scale of the solution has to be on par, on the same level as the scale of the problem itself. So we're trying to combat the certification. We might as well build a great green wall, as is the project in the south of the Sahel area. It's an international cooperation project, tries to stop the certification from penetrating farther south, in this case, from the Sahara Desert, and at the same time combats poverty and improves gender equality because women are most affected by droughts, etc. So it has multiple benefits, and it's an international cooperation project. Same at the urban context, the scale has to be on par with the scale of flooding, right? In these big river deltas, you need to have like flood-prone urban parks that can be inundated in case of big floods and protect the rest of the city from flooding itself. The same comes at the coastal level. We see here the NatMed Coastal Realignment Project in the UK, where they sort of rethought the entire seascape around the coastline area to make sure it was able to cope with flooding by somehow removing urban communities from the front lines of the coastal area and having some ecosystems there that could act as buffers. Not mangroves, because they don't have mangroves in this location, but just different types of coastal ecosystems that can be flooded and protect communities that have to be moved farther inland. Criteria number 3 is about improving and enhancing biodiversity in terms of connectivity, in terms of integrity. You see here a couple of examples on the urban context, where there's a different diversity of plants and trees and vegetation in general next to the roadsides or walk sides, and also protects or creates shade and creates a cool environment for pedestrians and cyclists alike. In the rural context, there are different ways of combining wildlife with farming or production of crops or different timber products, etc. Just making sure, for example, there's a corridor for pollinators to pollinate crops and increase production at the same time. So we need to give room, some space for nature to roam free again. In terms of regenerative agriculture, it's about combining, once again, agriculture with livestock farming, because that creates a synergy that increases the fertility of soil, that closes the loop of nutrients, retains water, and prevents erosion and flooding, etc. So regenerative agriculture, together with extensive livestock farming, creates a synergistic loop that provides multiple benefits to farmers and increases production and ultimately economic viability of small farms. There is an interesting example in Malaga, how they created these green corridors from the coastal line, which is a blue ring itself, towards the inland, connecting it with the forest close to the mountain range, so that biodiversity can also move around the city, interconnecting the green areas existing already in the city, so that there's enough habitat for species to thrive. Criteria number 4 is economic viability. And here a great example is the New Zealand Merino company. It's a wool production company that has created a whole value chain model that involves brands, fashion brands, with production of wool and other natural materials, regenerative materials, that ensures that all the production is being bought already by these brands in advance. So that creates economic incentives for small farmers or small livestock farmers in this case to increase their production, because everything is already ensured to be bought. So this economic viability is already ensured in that regard. On inclusive in governance, the design of NBS has to be done in an inclusive and participatory way, so that everybody has a say, has a voice in designing the NBS, and that makes sure that the benefits are shared in the most equitably and distributed manner. So a great example is the urban forest of Malaga, once again, in South Spain, where there's a civil society platform that encompasses civil associations, neighborhood associations, business associations, and the University of Malaga have put together this well-designed NBS that is going to create a massive urban forest in a very densely populated area of Malaga with benefits for the entire population. So it's been drawn up from the bottom up by civil society, and eventually the city council will take on this project and finance it. Another great example on the national level of Ecuador, the Ecuadorians decided almost by a large majority to protect the Amazonian National Park from oil drilling by a referendum. So that was a way to give a voice to the entire population, including indigenous people that were the protectors of the land and the water in that reservoir. Number 6 also is in balancing trade-offs. There's a lot of trade-offs in designing nature-based solutions, and you need to make sure you find the right balances in those. For instance, between climate and biodiversity, sometimes we're going to reforestate an area with just monoculture, one type of species of tree. That's going to, of course, sequester a lot of carbon, but that's not going to foster biodiversity. So we need to find the balance there. Also, with regards to livestock farming, in these very compact, concentrated farms, you can grow a lot of food, of course, but it's going to be very productive. But how about animal welfare, right? What's going to be the conditions that animals are living in those farms? Also between local and global economy, right? Sometimes you need to produce some products for export to other countries because the economy is that way. But once again, you created a lot of CO2 emissions through global transportation, global trade, while you should perhaps concentrate on feeding the local population first and then export the excess. But that's not always the case with our global economy, right? Then between practices and measurement. For small farmers, for instance, it's very difficult to measure the impact on biodiversity of regenerative practices because they need a lot of sensors, a lot of data management, and it's difficult for small farmers to be able to finance that. So perhaps we just have to foster regenerative practices that we know already in advance because of several research studies, etc., that work very well and produce certain results. And just foster best practices and don't focus so much on measuring on the local level by small farmers, and measure more on the regional level where you see the outcomes rather than the outputs, right? Other trade-offs include fair price and inclusivity. Sometimes the fair price leaves away a part of the market that cannot afford certain products. So making sure the fair price is also inclusive price. And this takes us to a couple of examples that put some food for thought. Green gentrification is an issue with an urban nature-based solutions because as you increase the quality of life for certain areas of the city through nature-based solutions, that also puts an incentive on housing markets to increase their prices, and once again leaves away a part of the population that cannot afford such housing prices, right? So that's an issue that has to be regulated through non-market mechanisms. Also, carbon offsetting is an issue because if we're going to offset our emissions in the global, from factories or industries in the global north by reforesting big parts of land in the global south that belong, for instance, to indigenous people, we're going to tell them, hey, you cannot use this land because it has to remain like that for us to sequester our carbon emissions. That's a bit of an unfair deal, right, for them, because it's their land after all. So perhaps we have to reduce our emissions first in the north and then consider rewilding options here in the north as well, rather than grabbing land in the global south. Adaptive management, of course, climate change is evolving, and so have to be their solutions to climate change, right? And for that, we need research, we need schools, we need farmers to be constantly retrained and retooled so they can, better and more effectively manage and face the evolving impacts of climate change, right? And the last criterion is on mainstreaming and sustainability. Local action is the key, but we also need to share best practices and be able to replicate models across the world. And for that, supportive models like FiberShed, I recommend you to have a look at FiberShed. It's a California-based company that basically is a structure of peer-to-peer farmers that just provide mentoring to each other and provide support to each other, and they hire legal advice, and they hire other types of advisors that together in this organization, what they do is just support new chapters that want to open and want to incorporate regenerative practices into the farming practices, and by providing technical advice as well as legal and financial advice, they make it easier for the model to expand and scale up impact. And also, sustainability of the NBS has to deal with the other SDGs, not just biodiversity or climate, but with a gender perspective, with inclusive design, with peace and justice and partnerships, and all the SDGs have to be addressed in the NBS by design. And lastly, what's the connection between NBS and the circular economy, right? Today's topic. So nature by design is able to close the loops of nutrients, of water, of CO2 or carbon. So just by design, these solutions work in a closed loop, just like nature does, right? And this is what we have to mimic in our hybrid gray and green infrastructure. For instance, we have the example of SUDS, Sustainable Urban Drainage Systems, that somehow close the loop of water in urban environments by recharging aquifers and regenerating wastewater from municipal and industrial use at the same time, by using several vegetation or retention ponds that filter the water and bring it back to the aquifers underground. Another interesting example is how nature-based solutions can be incorporated into green walls or green roofs that can, for watering the plants, can reuse and regenerate the gray water or the wastewater from the uses of the building itself. In the case of a hotel, from the rooms, of course, there are different types of filter can create a low quality water that can be reused for watering the plants. So with that, the NBS itself is not consuming additional water, but which is an important quality of NBS that do not produce an excessive consumption of resources. So that is self-sustaining in the long run. Another important use of water regeneration is for agriculture. We already discussed this one, the constructive wetlands. How can they regenerate urban wastewater and improve the quality enough for agricultural purposes? Like for instance, here they water an olive plantation, right? Just close to the regeneration plant. Also, regenerative agriculture or viticulture in this way, winemaking, is all about reusing the waste of pruning, for instance, pruning the vineyards to improve the fertility of the soil, just by leaving the pruning waste in there together with the vegetation cover that has to be there during wintertime. So we increase the organic component of the soil, and that increases the quality of the wine and the grapes. And we also can combine that with extensive livestock farming. For instance, we see here's sheep grazing around. So that, as they also produce poo, that's going to increase the fertility of the soil while managing the pests as well, and creating a feedback loop with another type of economy. That's a little bit the case. And of course, extensive livestock farming has multiple applications that ranging from making sure wildfires are under control by basically grazing across forests and across olive trees plantation and different extensive land uses in agriculture fields. The combination of small farming and livestock farming can once again create this incentive for shepherds to reuse these ancient methods of extensive livestock farming to make sure forests are well managed. And in that case, the reduction of wildfire risks is quite substantial. And in the case of regenerative fashion and textile, we've studied several best practices from companies like Fiberset, New Zealand Merino companies, Sechem, PA Flags, etc. And we see a lot of circular economy incentives and initiatives. Like, for example, in Pennsylvania, the production of linen has been relocalized, the whole value chain. So production and consumption is closer to each other. And there's been a revival in the textile culture, which had been outsourced, like in most Europe and most United States, textile production was outsourced to China and Africa, etc. So reviving those roots, those cultural roots, is important not only for economic purposes, but for cultural identity purposes. Right? And also the creation of cooperative models that incentivize small farming, because there's a certain critical mass of production that has some bargaining power when negotiating with brands for a fair price, right? So that's also circular economy. So those are some examples, but of course we can discuss more. For that, you have my email address, and feel free to contact me anytime. Thank you.
Thank you very much, Jesus, for the overview. I many times present nature-based solutions and circular economy. And if you don't mind, I really liked your approach. If you don't mind, maybe I will take a tip or two for next one when I'm presenting myself. But indeed, we have time for discussion later on. So people who would have questions or would like to add something, I would put a note, and you can ask it a bit later on. Maybe your questions will be answered by the real case study examples that we will also hear next on. And I would like to give word to Simos Malemis, who's coordinator of CARDIMED project, to present first case studies or a couple of case studies on opportunities for water use on islands. Simos, I see your presentation, it's not, and it is in full screen mode. So please go ahead.
Sure. Thanks a lot, Tadej. I think that Jesus made a very nice presentation and overview of the wide variety of nature-based solutions. And within my presentation, I will focus within the opportunities for water reuse in islands, and making particularly drawing from some of the case studies that we are dealing with in the CARDIMED project. Just to mention that my organization is the Sanitary Engineering Laboratory. It is within the Department of Water Resources and Environmental Engineering of the National Technical University of Athens in the School of Civil Engineering. So moving on now to tell you a couple of things about our project CARDIMED. It is a big consortium of more than 50 partners. And it is basically it's been funded within the mission's CLIMA calls, and it focuses on the biogeographical region of the Mediterranean. It's the orange, pale orange that you see here. These areas considered the biogeographical region of the Mediterranean. And in CARDIMED, we have basically 9 demonstration sites in 10 regions, and we are dealing with a number of nature-based solutions with more than 80 interventions. We have solutions for the urban environment, for the rural environment, industrial, and even peri-urban environment. So we have multiple types of environment. The idea is that we want to enable the transformation and to support the regions in the resilience for climate adaptation through the implementation of nature-based solutions. A parenthesis here that although the nature-based solutions have been considered in the European policy, in the EU policy, as solutions that can really help a lot, only in the water sector, only 5% of the solutions are actually nature-based solutions. So they're not really mainstream solutions. They are lagging behind the gray solutions. Our project is based on 4 pillars. One is the NBS itself, and the others are the digital technologies, the social and economic resilience, and the water, energy, food ecosystem nexus. And the idea is not just to develop solutions for each pillar, but to see how these pillars can work together in order to enable the NBS to move on to a regional level to support this transformation of the regions towards climate resilience. So here is an overview of the geographic spread of the different demonstration sites we have. We are covering pretty much the whole of North Mediterranean or South Europe, if you want. And there are different solutions. I don't have time to go through them, but we are pretty much tackling all the challenges. Water, heat waves, water scarcity, heat waves, floods, and other issues, biodiversity, etc. So I will now move on to the actual solutions that are related to islands. The vast majority of my presentation will be on the solutions that is already running. It's in the island of Lesbos, in the northeast part of Greece, very close to Turkey, where we have developed a completely circular solution to treat the sewage of a village, having a capacity of 100 cubic meter per day. That is around 500 people. So as you can see here, we have a combination of nature-based solutions that are the constructed wetlands and the agroforestry. But these solutions are actually integrated within the gray infrastructure which has been built. So we have anaerobic treatment processes, the UASB process, coupled with a 2-stage constructed wetland and disinfection in order to produce Class A water that is suitable for reuse. And I'm saying Class A water, that is the one used for unrestricted irrigation. And this scheme has been actually verified under the environmental technology verification. So a very long process. It took 2 years to take this verification. So in this scheme, we are basically recycling not only the water or irrigating an agroforestry scheme, we are recycling the sludge that is used after it is composted, and we are also recycling the nutrients that are inherently contained in wastewater. So we are valorizing a number of schemes, and I will show you also some pictures and some results. Here is a schematic plan view of the plant. On the bottom right, you see the old wastewater treatment plant is a typical activated sludge process. And on the left are the constructed wetlands. And there is also the composting scheme. And I will also move to show you some more precise pictures of the scheme. So we apart from the main constructed wetlands, we also have sludge drying reed beds for the sludge that are basically dried here. Here is an overview of the unsaturated constructed wetland. And we also have some smaller pilot testing wetlands that are more intense wetlands that can actually decrease the footprint of the scheme. Here is the irrigation area. It's basically an agroforestry field, around 10,000 square meter. where the agroforestry is basically a combination of trees with annual crops and herbs that is irrigated solely with reclaimed water. Also here you can see some maize cultivations from the agroforestry. And also we have been monitoring the plant for more than 4 years. These are some results we have produced. And you can see the very low levels of total suspended solids, less than 10, the vast majority of the cases. Ammonia is also very low in the effluent, below 10, but you also COD is very low. And generally the water, the claimed water qualifies for unrestricted irrigation, both based on the Greek, but also on the European regulation. Now, in terms of energy consumption, small-scale systems are criticized that they are energy inefficient. And you can see here the schematic from reference showing that the C and D here are the most energy intensive plants that are the smallest one. In our case, because of the recovery of the energy through biogas from the anaerobic process, but together with the fact that the constructed wetland are passive systems, we are able to have low energy consumption of the order of 0.7 to 0.8 kilowatt hour per cubic meter. This is very low compared to the around 1 to 1.5 kilowatt hour per cubic meter of small-scale systems activated sludge processes. Here I share with you some pictures. On the top are the constructed wetland, and on the bottom is the agroforestry system. Actually, the trees that were planted were very small when the system started, and now they have grown into medium-sized trees. One thing that we did, we tested in a 2-year analysis the biodiversity effect to the soil. So the basic research question was, if you fertigate instead of irrigating, do you support soil biodiversity or not? And the results were quite impressive, that we had a big increase of the nematodes that are a very good indicator of soil biodiversity. So during the period of that we were irrigating, and we see an increase. The green is the treated the soil that they received treated wastewater, while the control one with tap water was the blue one. So there is no adverse effect in terms of toxicity. We saw that, but there is also an enhancement of biodiversity. Through the operation of the scheme, many products have been developed, and we have set up a very nice local supply chain. So the products that are developed in the agroforestry are actually given to the local market. And we also have farmers, but also livestock producers, that they take the maize, for example, for their animals, or the vegetables are given to local markets. Now I will move on. I think I have 5 minutes today. For 5 minutes, very briefly, I'll try in 3-4 minutes to explain this novel rainwater harvesting solution that we are implementing again as part of CARDIMED project in the Nicosia municipality in Cyprus. This is actually in the phase of construction. Design is finished. And the idea is that we go and intervene in a completely urban environment in a local park, and we develop a rainwater harvesting solution, a subsurface rainwater harvesting solution, so that the rainwater actually drains through this inside the surface. It is collected out underneath the surface. It is stored and then is used for urban greening. And the idea behind this lies in the implementation we did in Mykonos Island a few years ago. This is also part of the project of CARDIMED, where you can see on the left, this is a subsurface rainwater collection system. So the water drops here. There is an underground impermeable geomembrane and a collection system of the water, and it's collected in the tanks and then used for agricultural irrigation of here it's of oregano. So this concept we actually retrofit in a park in Nicosia using permeable type of concrete. And basically this hydropark, as we call it, the water drains inside, collected and used. You can see on the right the intervention with the colored surface, different colors. So it's also a park. So we want to attract people, and we are integrating this with more green, with shade, with pergolas, and with tables. So we make this something not only an NBS, but something very attractive for the people to for amenities. We within this scheme we employ a number of infrastructure apart from the permeable surface where through which rainwater drains. We also have a precision irrigation scheme in order to minimize the amount of water that is used for the green. We try to make it as much as possible attractive through interventions in the lighting, but also we support biodiversity by promoting plant and tree plantation. And last but not least is in the island of Ferla, where there is a green wall, already developed solution in order to treat the gray water of a school. And you can see here the students that have been using this green wall. The separated gray water from the sinks is actually being used to treated by this green wall, but is also used to irrigate it. And then the treated water is actually recycled back for toilet flushing. It has also received a lot of attention in the local population. As Jesus mentioned, if the solutions are not accepted by the law, more importantly, co-developed with the local community, it is very difficult for them to be accepted. So in all of these solutions, before doing anything, we sat with the local stakeholders, explaining the solution, took their feedback. This is a very big step, the community involvement and co-creation. Otherwise, there is a big chance that these nature-based solutions are not well accepted by the locals. You can see here some of the CARDIMED social media. We have the website, the LinkedIn, the X account that you can visit, and we regularly try to keep them updated. Thanks to Azul and David. So back to you today. Thanks a lot, and I'm open to any questions.
Thank you, Simo. Again, the recommendation is that the questions are asked at the end when we have an allocated time slot. And I will go straight ahead and give a word to Raquel from Cardiff. She's a coordinator of NatMed project, and she will present a case from Seville, but she will tell more, so please go ahead.
Okay, so I'm going to share my screen, just a moment. Okay, can you see it? Yeah.
Yes, it works. Yes.
Okay, perfect. So, well, first of all, thank you to everyone for joining this webinar. I'm Raquel Marijuan. I'm the coordinator of the NatMed project, and I work in Cardiff, that is a technology center in Spain. In this presentation, I will briefly explain an example of the NatMed project, mainly to explain the link between constructed wetlands and circular economy. So, well, in this presentation, we'll see a brief introduction of the NatMed project, and then we'll move on to the link between constructed wetlands and circular economy. And for that, we'll see an introduction of the case study, the what are constricted wetlands and their contribution to the circular economy. And then we'll see some current barriers and challenges and opportunities, and we'll end with some conclusions and key messages. So the NatMed project is part of the PRIMA program, and its main objective is to develop, apply, and validate several nature-based solutions that are combined into full water cycle MBS. And these solutions are integrated into existing grey or natural water infrastructures, and also are based on specific phases of the water cycle, with the objective of optimize the water-related and dependent ecosystem. At the end, the objective is to address the challenge of water management, water scarcity, and seasonal balance in the Mediterranean area, also supporting economic growth and resilient societies. As you can see on the map, we are developing in this project 5 case studies that are implementing this type of nature solutions. One case study is located in Spain, other in Italy, in Greece, in Turkey, and also in Algeria. And in this presentation, I'm going to focus on the case study of Spain that is located in Carrión de los Céspedes in Seville, in the south of Spain. And specifically, it is located in an experimental center for new water technologies. And this center is a living lab for the co-creation, experimentation, and evaluation of innovative wastewater treatments. And in this part of Spain, and also, well, it's general for the Mediterranean area, the main challenges that they are facing are water scarcity, droughts, the quality also of the stored water, the high rates of the evaporation, and of course the impacts of climate change. Then the objective of this specific case study is to treat and reuse wastewater for irrigation, improving the quantity and the quality of this water when it's stored. For that, the main nature-based solutions that they are implementing are constricted wetlands that have already been mentioned, but also other solutions as floating gardens and ultrasounds. But in this case, we're going to focus on the constricted wetlands, mainly because of its link with circular economy. So just to give a bit of context, what are constricted wetlands? They are a type of natural solutions. They are treatment systems that use natural processes that involves wetland vegetation, also soils, and their associated microbial, biological, physical, and chemical processes to improve water quality. So their main benefits are the removal and filter of pollutants from water, the capability to treat wastewater, also to manage stormwater, and to create wildlife habitats supporting biodiversity. So in this case study, you can see an image of this center that has several and many types of constricted wetlands. Now I'm going to the treatment process, how it works. In the first place, the constricted wetlands are fed with the outlet of an IMOP tank that has, and this water has been previously pre-treated with some thick screening, descending, and also degreasing. And the origin of this water is urban wastewater. Then this water passes through the constricted wetlands, and what we are doing in the project is evaluating the combination of 10 types of these constricted wetlands to optimize the pollutant removal performance. And after that, the water passes through a post-treatment train that it's composed by ultrasounds for the removal of certain parameters as the microalgae and the E. coli, and then it's followed by a filtration system, and at the end, it is used as irrigation. So as I mentioned before, the plant is composed by many types of constricted wetlands, and in this case, in this project, we are evaluating 10 types of constricted wetlands. Sometimes they work in hybrid configurations as the vertical surface flow plus horizontal subsurface flow. Also, they can work individually, as is in the case of vertical subsurface flow. Another type of hybrid configuration is the vertical subsurface flow plus free water surface constructed wetland. Also, we have two types of floating helophytes wetlands, aerated treatment wetlands, and also the French vertical flow wetland. So we evaluate how these constructed wetlands work independently to see which ones have the best performance, and this way we are able to see the optimal combinations between constructed wetlands. And also, well, after the water, after passes through these constructed wetlands, is reused as irrigation. In this case, in an olive grove. This is an area of 1-2 hectares, and there are 400 olive trees. And in this case, it is really important the monitoring of certain parameters to see how the constructed wetlands works and the impact they have in not only the water quality, but also the soil quality and the biodiversity. And for that, we are monitoring the removal of nutrients by the constructed wetlands and the water quality. That means that we are monitoring several parameters like nitrates, ammonium, total nitrogen, phosphorus, etc. And we monitor these parameters before and after the constructed wetlands, also to see the impact. It's also really important to evaluate if we are compliant with the European Union regulation with the requirements for the water reuse for the irrigation in agriculture. And another important part of the monitoring is to evaluate how this water is affecting the soil. That's why we also monitor several parameters regarding the organic matter content, the pH, the conductivity, also the phosphorus, the potassium, etc. And the main idea is to evaluate how this water is influencing in the soil. And how is this related to the circular economy? In the first place, because we are reusing and recycling water, the treated water from the constructed wetlands can be reclaimed for several purposes. As I mentioned before, this water can be used for irrigation in agriculture, but also in urban areas. And they can be used also for other purposes, for example, to recharge for aquifers, for groundwater recharge. This way, we are providing additional water sources and reducing the water dependency and reducing as well the pressure on freshwater bodies. Another key point related to the circular economy is that the irrigation with reclaimed water by constructed wetlands is enriched with nutrients like nitrogen and phosphorus. So this way we are improving the soil fertility and the agricultural production, and also we are reducing the use and demand of fertilizers, and also avoiding the energy and the environmental costs that are associated with their production, distribution, and application. Also, the algae and the biomass generated by constructed wetlands can be harvested for bioenergy production, soil amendments, or other bio-based products. But of course, currently we are facing several barriers to replicate and implement a larger scale constructed wetlands. Some of these barriers are related to the lack of holistic and long-term impact assessments that includes the evaluation of all the co-benefits of these type of solutions, for example, the carbon sequestration or the circularity contributions. Also, there is a limited availability of the cost-benefit analysis tools that are tailored to NBS, and this makes it difficult to compare this type of solutions with the traditional grey infrastructure. Also, the insufficient integration of the circular economy perspective within natural solutions planning and implementation, as usually natural solutions are often treated as isolated interventions. And also there's an issue related to the social acceptance. Sometimes there is a negative perception of reclaimed water, and also related to the shortage of trained technical personnel for the design, operation, and maintenance of this type of solutions. And finally, also, well, the limited inclusion of nature-based solutions and also circular solutions in training programs and public policy frameworks. But also there are some opportunities related to the constructed wetlands implementation, as they are long-term and cost-efficiency solutions compared to traditional ones. They are low operational, they have low operational and maintenance costs, and also they provide additional indirect savings, as we have seen, like the resource recovery. They are closed-loop systems. For example, the case of the reuse of water and the provision of nutrients. Also, they support the creation of local employment, and they have a socioeconomic value, especially in rural and peri-urban areas. They have a high potential for replication in other regions, as they are flexible and really scalable solutions, and they provide stable and safe new water supply sources. And this is particularly important in context of droughts and water scarcity. So just to conclude, constructed wetlands are effective, nature-based and circular solutions for water treatment, and they are able to address a growing challenge like is water scarcity. Also, by enabling water reuse and circulation, constructed wetlands contribute directly to the principles of the circular economy, and this maximize their co-benefits and has a positive impact in soil and environment. And to maximize their impact and their replication potential, it is really important to conduct holistic impact assessments that includes the cost-benefit analysis and the circularity indicators, also to improve the social acceptance through awareness and engagement, and to develop dedicated regulatory frameworks and strategic policy support. So that was all from my side. Thank you very much. And if you want to check more information of the project and all of this case study and the other case studies, you can always visit our project website. Thank you.
Thank you, Raquel. You had an elaborate slides with conclusion and key messages. You may escape a couple of questions with this, but we will see at the end. Let's proceed and continue with the case study from DesirMED project. We have with us Joaquim Carvalho from Portugal, who will tell you more about the case study at Fundão municipality. Apologies for any problems with pronunciation, but please, Joaquim, go ahead. You're muted. But you should have, you have presenters, right? So
I think it's permitted now.
Yes, it works. We hear you.
All. Yeah, I will try to share the presentation. I don't know if you can see the presentation right now.
It works, but it's not in presentation mode yet. Now it disappeared.
You can see right now.
It is on. I see the slide number 2. Again,
Number
not in the...
With some delay. And right now you can see the presentation. Yeah.
Joaquim, I still see... Yeah, well, I see the presentation, but not in full screen. Now, I'm personally not bothered by this, but perhaps you have to swap. There's an option to swap.
Yeah, and right now it's possible to see or not? So if not, I think it's possible in this screen. You can see it. Yeah.
Yes, we see the screen. Maybe we proceed like this. Sorry for.
Yeah, I don't know why it's not possible to put in full screen. So the coordinator of the project is not possible to be here. So I'm the technician of one of the technicians of the project. So I will try to send you the Portuguese message from the DesirMED. This is the countries that are involved in the project in the Mediterranean area. In Portugal, we are focused in this central area. This is the intermunicipal community Beiras and Serra da Estrela in the center of Portugal. It will be involved 15 municipalities, and we are focused in the center in the municipality of Fundão. We produce some crops and some traditional products with AGP and PDO certification. The main regional climate hazards, the current climate impacts and vulnerabilities. It will be the high temperatures we are feeling in this moment, cold waves, excessive rainfall, and forest fires. The forest fires is the main problem we have in Portugal in the last years. The climate projection decrease the average annual rainfall, increase in average annual temperature, and increase in extreme phenomena. You can see in the news every year the problems we feel in Portugal and Spain is normally the same problems. The planet solutions, since the financial sectors, health and safety, peoples and goods, transport infrastructure and energy, governance and territorial planning, and we are focused in my work in agriculture, forestry, water resources, and biodiversity. The main objective of DesirMED is testing and demonstrate innovative solutions with a focus on natural-based solutions capable of promoting resilience to the effects of climate change in Mediterranean countries. In the case of the fields experimentation in fields for forest, creation of landscape mosaics, the main goal it will be to stop the fire, the extension of fires. So we create new landscapes to install new crops and to stop, in case of fires, this continuity of the fires. Acquisition and testing of a forest monitoring system using drones and satellites, adoption of measures that contribute to the recovery of the ecosystem, reintroduce native plants resilient to the climate change, reductions of soil erosion with the installers of pastures, and reduction of fire risks. So the animal production, it will be an important step to introduce in the forest locals. Experimental fields for agriculture, testing crops, new crops, for example, forage that adapt to the region and show good resilience to the high temperatures. Strengthening the LoRa network, the Smart Trap network, and weather stations network to collect information and issue alerts to the farmers, quickly alerts to the farmers. Acquisition of intelligent irrigation systems for studies of irrigation allocation to be considered, and the practice of deficient irrigation. Tests for agriculture valorization of organic byproducts. This is some solutions we have installed in Fundão. For livestock farming experimental fields, we will test for extensive grazings, especially in mountains, improved pastures at altitude, soil regeneration, test field using, or holistic livestock management, and to collect all the data included for animal production. Acquisition and for livestock farming, acquisition and testing for georeferencing equipment, animal monitoring, and virtual fences in mountain grazings. Creation of a center for animal selection based on feed efficiency of cattle intended for extensive grazing, testings, and reuse byproducts in animal feedings. This is a small video, the example of the barn we are making to choose the best animals to feed efficiency and to select the animal it will be more efficient. So for my Portuguese parts, thank you very much, and sorry for my English is not so good.
Thank you, Joaquim. Your English, I understood everything, so your English is good enough. No worries.
Okay, thank you.
So thank you also for the third case study of DesirMED. So all three projects highlighted how, or selected case study or more that they highlight the value of circular economy. In fact, the DesirMED coordinator is here with us, Elisa Forlan. I will give word to her. Elisa will moderate a small discussion among participants. So in case anyone has a question or has something in mind to ask, now it's an opportunity. You can raise hand and we will allow you to speak on microphone. And in any case, I give word directly to Elisa to take it from here. Joaquim, just to say, if you can stop sharing, or can I stop sharing for you? All right. Thank you. Elisa, go ahead. You cannot unmute. You are as a presenter. Sorry for this. I will. Can you try now? Allow your microphone. I will again make you a presenter. For a small test, David, you are an attendee. You don't have you're not allowed to unmute yourself, but I'm allowing you now. And could you perhaps test?
Yeah, now I can. Yeah, if you give me the permission.
Okay. So I'm again taking it away from you.
Maybe today Elisa could leave the room and enter again. Maybe that could fix the problem.
All right, so she already disappeared. We're waiting for her to join back. Maybe instead of taking over, I could use this moment to unexpectedly invite Sophie Berger, who I see among the attendees, in case she would have a word or two for us, or perhaps a question. This was not planned, so I'm not sure if Sophie, you have any other obligations, or if this is possible, but in case you would have a word for us until Elisa joins back.
Hello, hi. Thank you for putting me on the spot like that. I didn't necessarily expect that, so it's going to be very much improvised. But first of all, I'd like to thank the three projects for working together on similar issues, because it is really important to collaborate as a way to increase the impact and to learn from each other. In terms of questions, this is a very a question on a very detailed, but I was wondering actually, the Cyprus site that you mentioned. What is the timeline for that one? Is it something that is going to happen soon, or like when are you going to have things visible? Also, yes.
Thank you for the question. It's actually now under development, I would say. The initial works are starting. The timeline is end of August, according to the grant agreement, but we will probably have a couple of months of delay. So I would say October, or maybe November. We should have everything in place. Some of the systems that are coming, because I only presented like 1/3 of the demo of Cyprus. There are also another two that have to do with algae, treatment of groundwater with algae. So there are a couple of systems that have been ordered and are under construction outside Cyprus and are coming within the next few months. So we expect October or November to have everything in place and operational.
Okay, so that's thank you. That's very useful also for some planning.
Thank you, Sophia. And again, apology for throwing you on the spotlight unexpectedly like this. I had to seize this opportunity though. Really nice that you joined us here. In the meanwhile, I see Elisa back with us.
Yeah, I'm back. I'm really sorry. And now it seems that it's working. So
Indeed it is.
okay.
We hear you very well.
Yeah, thank you so much. So people that are connected, please feel free to raise your hand and pose your question. I can break the ice a little bit in the meanwhile. And I have a question for Simos, but also for Rachel. I mean, they are a little bit connected. So in the solution that you show, Simos, for the island of Lesbos, you say that around 100 people were engaged. So I was wondering how the local knowledge, the indigenous knowledge, was then used for shaping the nature-based solutions, circular approach that you show us.
I mean, the system itself is servicing 500 people. 100 is the sewage that is treated. So 100 cubic meter per day is the sewage, and this corresponds to 500 people. But if we're talking about how these solutions were communicated and co-developed with the local community, that is something different, because the actual solutions, we had to sit down with the water utility because they were the ones that developed the portfolio of the solutions to be actually to make an application to get the license, the permit. So we had to, from the very beginning, even before CARDIMED, this happened as part of another project, we had to sit down with the local water utility, discuss, explain the solutions, and arrive to a conclusion that it would go for wetlands, which is not a mainstream approach, because in Greece, 95% or maybe more of the wastewater plants are grey infrastructure, activated sludge processes. Regarding the agriculture itself, we had a couple of ethnobotanic workshops where we sat together with locals. The team sat together with locals and they explained to us what kind of species are the most well adapted to the local environment and of interest to them. So we took through these workshops, we kind of co-developed the agroforestry system together with the locals that have, local agronomic expertise on what grows and what doesn't grow. But now the site is actually has a very high visibility at a European level, I would say, because we have groups, we have schools, we have researchers that come across the whole of Europe to visit the system. So it's not only local, it has a, I would say, European effect, let's say. And there is also the transferability of this solution in a couple of sites in Italy, in Gorgona Island. They took some national funds to implement, let's say, a transferability of this solution there.
You already replied to my second question. I wanted to understand what is the potential for transferability and if you are ready. But I know you are the coordinator of CARDIMED, so everybody's engaged in scaling up natural-based solution. This connects also to the question that I had, because I don't see hands rising currently. So please, guys, don't be shy and pose your question. I can continue for the whole day, but anyway, for Rachel, for you, you also say that there is a matter in terms of challenge of the social acceptance, so the negative perception in terms of reclamation water. And this is a topic that I addressed as well while working in the Apulia region, in the southern part of Italy. I mean, whether, let's say, the topic of water management, water availability is quite prominent given the, let's say, the pattern in rising temperature and the water availability. But there's still this friction, let's say, from the, let's say, farmer and the rural system, people engage in these activities to use reclamation water. So how do you think that this challenge could be, let's say, to try to overcome this challenge? And how also this project can help on this on facing it?
Okay, well, I can explain what we are doing in the project. At the end, we are trying to engage with the end users, that in this case are the farmers and all the agriculture sector, mainly so they can understand how this solution works and the benefits of this type of water. And also it works bi-directional because we also want to understand their barriers and their perception of this type of solution and how they, their challenges to adopt this type of solutions, because they are addressing many administrative challenges. And for them, that is like the key point, that they have to do many papers, and that's like overwhelming for them. So I can say that that's their main challenge to address in this type of context and with this type of stakeholder, the bureaucracy. It's not that they have, in our case, I mean, what we have seen is they have a positive view of this type of solutions, and they understand that the water scarcity is a problem, and that the constructed wetlands provide an additional source, a secure source of water, and also that it has benefits for the soil. But the problem for them is the bureaucracy. So, but maybe that's not for all the cases.
No, definitely. I mean, this is what emerged also from our case study, let's say, not directly engaged in DesirMED. And today, let me ask the last point, because I was also curious, because in DesirMED, we have, let's say, a similar approach with constructed wetlands in Greece, in Eastern Macedonia Thrace, and they are also investigating, let's say, the potential of this solution for emerging pollutants. So I was wondering if it is something that you are investigating as well, and let's see, creating synergies.
As I mean, I'm the coordinator of the project, but I'm not the leader of the case study. I know that they have many projects and they investigate many things. So I think Isabel is here. So maybe you can answer this question if you are, because I think not in the project, not in NatMed, but maybe they have another project that address this issue. I don't know if Isabel is connected. If not, we can.
Yeah, definitely, no problem.
Yeah.
I see.
Okay.
Yes, I am here. Hello to everyone. Thank you very much. for so interesting event. And thank you, Raquel, for the presentation of the case study in Spain. Well, relate with the micropollutants and in the frame of the constructive wetlands. In the frame of NatMed project, really, we are not working in this issue in the frame of this project. But it's true that we are involved in other projects where is evaluate the performance of the constructive wetland for the removal of some micropollutants. And really, when this kind of system is working in an hybridization model, really the performance for some micropollutant is really high. So this is a natural solution that could be taken into account in the frame of the removal of this kind of pollutants.
Yeah, you're perfectly right. I mean, I've seen the case study in the Albufera Lagoon in Valencia, and then I've seen also in Eastern Macedonia Trace, and the potential is very high. Today, it seems that you are thank you so much. You are stepping in today.
I'm actually, I have a slightly different question than constructed wetlands, so I don't know if Simos has a direct reply on that. Perhaps he should go first.
Yes, actually, that's why I raised my hand, because in the scheme of the wastewater, the circular wastewater management of Lesbos, in the past we have undertaken a complete monitoring, the consortium, I mean, of targeted micropollutants, mainly pharmaceuticals, but also other compounds. And what we saw is that the integrated process consisting of anaerobic treatment plus constructed wetlands removes around 75 to 80% of the compounds. Of course, there is a variation depending on the type, but we also did analysis on not only on the water, but also the soil, but also the crops, some targeted crops. And we did a risk analysis, both for if you are discharging in the river, in the nearby river, so if it affects the aquatic ecosystems, and also regarding the consumption of the crops. So we targeted, if I remember correct, was lettuce, tomato, and lavender. Or maize, and what we saw is that the level of there is some accumulation of some of the pollutants in the crops, but not to a level that is poses a risk to the population. That was the main, let's say, output.
If there's anything more on constructed wetlands, perhaps the discussion can continue.
Yeah, I mean, I'm very curious on this type of solution, honestly. Maybe, I mean, I don't see hands rising. I have a question for the DesirMED case, so for you, Joachim. I mean, I'm pretty conscious of the case study as coordinator, as you can imagine, and I know that the engagement of the local community, I mean, the mantra of Fundao is that people lies at the center of transformation. So now it's the DesirMED mantra, as you know. So also in this case, I was wondering how the local knowledge is embedded and is used in shaping, in designing the solution that is promoted by the municipality.
How we can find the solutions and to show the data collected is your question, Elise.
How, let's say, the local knowledge is used within the design of the solution, because I know that there is also this innovation strategy in Fundao City that really engage the people also for creating new job opportunity. It's creating a wider, let's say, loop within the world of nature-based solution.
Yeah, we'll in our case in the EPCB, in the School of Agriculture, we can work with the associations and the farmers directly and show the information with them. So, and the municipality of Fundão are trying to do the same, to work directly with the farmers and the people around in the city. So if we can show to the farmers the best solutions to they implement in their cases, in their farmers, we must to find and to collect the precisely data and to show them the way they have to run, to see what is the best production system they have to install to this weather conditions we are fighting in this moment. Yeah, we must to study and find the best solution and to find with them, with the associations of the farmers, it will be the best way.
Yeah, definitely, because they. This is why I mean also the question. I mean, local knowledge, and also Simos was saying that also this botanical knowledge. I mean, local people can share something that is not written on a scientific paper, but is very well known from the community. So, yeah, thank you so much.
Thank you.
I don't know today if I have time for a last question, maybe for Jesus. That is more, let's say, a overarching question. Given that you presented a wide array of, let's say, natural-based solution exploiting, let's say, the circular approach in their design and implementation. So, and I was wondering what innovative business models or partnership you have seen emerging at the NBS circular economy interface that we can learn, given that in all our projects we have this work package on business, economic system, and the way of, let's say, funding nature and funding natural-based solution.
Sure, thanks, Alice, for your question. So we've seen a bit of a revival of all professions in rural areas, like Sephardin, because now they're using waste products, byproducts from agriculture. I'm talking about waste from pruning the vineyards, waste from managing the forests, etc. So there's been an appearance of schools for Sephards, for young people to be re-attracted back to rural areas and take on this all of professions. Also, we've seen some, biocircular economy companies that are emerging in rural areas, just giving value back to, the managing of natural capital in general, from ecotourism activities to timber production, from sustainable forest management, of course. Also, anything that has to do with making sure our natural parks, natural areas are well preserved and well maintained. So this need of people sort of managing the land. So rangeland management is important as well, and also custody of the territory in terms of agriculture, but also livestock farming, and also forest management, wetland also restoration. So there's plenty of wetlands that have integrated over time, and they provide a lot of benefits as well for rural communities. So there's a need for science in rural areas. There's a need for innovation in terms of using byproducts from natural capital management. And of course, also reusing the knowledge of ancient cultures or local populations that have been aging, and the wisdom is not being exchanged between older and younger populations. So there's a need to reclaim that knowledge and combine it with innovation to attract young people back to the land and use the ancestral knowledge for climate adaptation, which is fundamental. I'm talking about seeds and talking about native species that are more adapted to climate change. So combining that ancient knowledge with innovation is fundamental for new businesses, and also bringing in the financial sector, which is lacking a little bit. I think they need to see the benefits of really restoring the ecosystem services in rural areas as a way to provide services also to urban areas. So financial services have to see the long-term picture a little bit and the long-term return on investment. So changing the mentality of the financial institutions is fundamental as well. So there's a need for fintech innovation.
Yeah, thank you so much. Let's say some keywords. So basically, education, So also to create a academic pathway which can train people and the new generation on the concept of nature-based solution, but also, let's say, on the concept of, let's say, taking care, let's say, of our land, of our environment. On the other side, also talk about a matter of governance, so the people managing this territory, and a matter of territorial sovereignty. That is an issue, for instance, in the, let's say, in some northern part of Italy, mountainous area, where, let's say, there is a trend of the population, and this connected to your last comment that we have to keep traditional knowledge and, let's say, reattract the youngest to take care of this, let's say, not forbidden, I mean, that we are forgetting territory. So yeah, a lot of input, traditional knowledge, not only local knowledge. Yeah, and also from the CMOS, if you remember from the Mission Forum on Climate Change Adaptation, it also emerged this concept of growing a new generation, let's say, with the academic pathway, completely dealing with the transformative climate adaptation and nature-based solution. Yeah, thank you. I mean, not so many hands rising, but yeah, I think that a lot of valuable input and insight, let's say, came up. And today I leave you the floor to develop.
Yeah, thank you, Elisa. After all, it is Friday afternoon, so thank you for everyone being here. I think that the fact that we're going a little bit over time does mean that there's a lot of exchange, if nothing else, between the projects themselves as well. I would maybe add at the very end that in all the presentations, it was mentioned and clear that stakeholder engagement and basically the end users are important. Raquel was mentioning working with farmers. It was good to hear that mantra of DesirMED is that people are in the heart of adaptation or transformation. And I think that at the end, so it's about capacity building, it's about awareness, it's about knowledge, but it's also about trust and practicality, and having in mind the circular economy and theme of this year and the direction of competitiveness. Perhaps circular economy is an angle for nature-based solutions to really bring them closer to end users, whether farmers, citizen municipalities, to see the value and understand the benefits, the multiple benefits that the nature-based solutions provide. I will let everyone know that this meeting is recorded, and we will publish it and share it also with the other co-organizers, so they can share it with their through their channels. Perhaps if for people who are still here and are comfortable enough to turn on the camera at the very end to maybe take a short photo before everyone start our weekend, I invite for everyone to turn on the cameras, David to take the print screen when some will appear, and then we will close this meeting.
Okay, thank you to everyone. So smile now, that's your opportunity. Okay, that's it. Thanks to all of you. So have a nice weekend.
Thank you, David. Thank you to all the speakers, and we will be in touch soon.
Thank you.
Bye.
Bye-bye.
Thank you.
Thank you.
Bye.
Bye.
Thank you.
Bye.
Bye.